So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 23 of the Apply Daily Leetcode challenge and we have again a hard level question in front of us. It's again like continuously 3 days in which we are having hard problems. So let us see what the question is. It's question 1416, restore the array, okay? So let me quickly give you a guess of what the question is. But first of all, to understand this, there are only two inputs given to us, okay? And we have written an integer, okay? So let us quickly understand what S and K are. Okay, these are S and K. What are they? Let us quickly understand. So what was happening is we were printing numbers, okay, integers between the range 1 to K. Okay, but what happened is the program forgot to print the spaces between the numbers. Okay, for example, you can say KS uh, 2000. Okay, KS 2000. Okay, so for example, one was printed, then 3 was printed, and then 17 was printed. Okay, but what happened is the program omitted the spaces between them. Okay, the program forgot to put the spaces between the integers. Okay, and it printed it directly. Okay, so now what they are asking is, given that we know k, okay, k means the numbers that we are going to print is going to be in the range 1 to k. Okay, so k is 10 means the numbers are going to be 1 to 10. Okay, if k is 100 means the number can be anything like 39, 40, 50. So at once what is happening is 30 will be printed, 40 will be printed. Okay, and then the space should have come, and then the next number. But what happened is the program omitted the spaces. Okay, for example, in this case, if you see, it could have been 10, then a 0, a 0. But what happened is it omitted all the spaces. Program it printed as 1000 as such. Okay, that is the given question. What they're asking us, given the string s and the integer k, return the number of possible arrays that can be printed as string using mentioned program. They are asking us to predict what could be the possible array of the numbers. They're asking the total number. Okay, so what could be the total possible number of arrays that could be printed given the order is this. Okay, given this order and given that numbers are between 1 and 1000. Okay, this thing is very important. It's 1 only, it's not 0. Okay, this is going to be else condition in our program. Okay, this is going to be a base condition. So remember this thing very carefully. It's going to be 1 and not 0. Okay, so to make you understand the program very cleanly, let us see this. Consider 317 here. Okay, I will in program also I will trace and show you for this, but for now let me show you in this. Okay, so for if we consider 317, number of ways to print 317, let us see how it can be printed. Okay, I'll just increase the font size. Okay, yeah, number of ways to print 317. Yeah, you can first see that I will select the first integer first. Okay, I will select the first integer, and then I will calculate number of ways to print 17. See, I have selected 3 now. This is I am telling how I am going to code it. Okay, just trying to understand it. First, select the first integer, and then calculate number of ways to print 17. How many ways you can print 17? You can print 17 either as 1 7 or 17 as together. Okay, so now I put 3 to it. Okay, now it becomes 317 and 3 comma 17. Okay, now I will print 31 together. Okay, print 31 together, and then find number of ways to print 7. There is only one way to print 7. This. Okay, so it became 31 comma 7. Now select all the three together. Okay, it became 317. I will again repeat. See, just try to understand the logic. Suppose my essay is 317, how many ways to print it? Okay, given that k is 2000, that means these numbers are going to be either starting from 1 to 2000. Okay, these numbers which you are seeing here now. See, 3 comma 17. 17 is printed separately, 3 is printed separately. Okay, 17 is going to be from 1 to 2000. That is the meaning of k. Okay, I will quickly advise you to pause the video once and again read the question twice. Okay, see, read the question as many times as you needed, because see, only if you are very clear with the question, then you will understand the solution. It's not a hard problem basically. It's going to be very easy if you understand the solution. Okay, simple recursive approach, you can get the answer. Okay, so yeah, and see, if you try to answer this example, also it will be more than enough. Okay, see, first select the first integer 3. What are the remaining characters? 17. I will now try to calculate how many ways you can print 17. Okay, how many ways you can print 17 by either 1 comma 7 or as 17 to as such. Okay, now append 3 to it. Now append just 3 to it. Okay, I select the first character and I found the ways. Okay, there are two ways. If I will select 3 and then I find try to calculate manipulate with 17. Okay, there are two ways. Now I selected 3 and 1. Okay, one more character, 3 and 1. Okay, so 3 and 1 are together. Then we will try to calculate the number of ways in which we can print 7. Okay, you can see we can print 7 in only one way. Now I selected all of them together. How many ways you can print all of them together? So there is only one way in which you can put all of them together. Okay, that was the idea. Now coming to the solution part of it. Okay, the coding part of it. See, there is one more thing. We have to return the answer 10 power 9 plus 7. Let me tell you this very frankly. If you see, there are many ways of doing it. Either in each step we can do it like this, I have like the way I have done, or you can say you can just return the answer finally as a modulo. Okay, but let me tell you, if you are not doing in the intermediate steps, you are not taking the modulo 10.9 plus 7, you will get time limit exceeded error. Okay, I also face the same. Okay, so the idea is in each calculation you have to do modulo this number. Okay, in each calculation, not only in the final answer. Okay, this was also one hint. Now please try to code it yourself. If you are not able to do it, then only see the solution from here. Okay. Now let me discuss you my code. I am first calculating the length of the given string. Okay. I am making a cache. Okay. You can call it as a cache. Okay. Let me tell you how it works. See, GP of I is number of ways to print from the ith character onwards. For example, see, here I told you what is the ways to print 317. So in this example, it is going to be DP of 1 because we are starting from the first index till the last. Okay, this is the meaning of this. DP of I means the number of ways to print the string starting from the first character. Okay, at the ith character. Okay, so in this case, see, please understand this very, very keenly. Okay, in this third example, DP of 1 is going to be 4 because we had 4 ways to print it. Okay, DP of 1, see, these are the ones. I will just put some space here so that it becomes very clear to you. Okay, yeah. So DP of 1, that means number of ways to print 317 is going to be 4. Okay, that was the idea. Okay. Okay, first, before going to the code, let me explain the examples. That would be better. Okay. So they are asking this. They have given this as the print output, and we are given k. It's 1000. Some okay, it's 10,000. That means the numbers can be from 1 to 10,000. Remember 1 to 10,000, not zero. Okay, so one can be printed alone. Okay, that is fine. But what about zeros? Zeros can be printed alone. Okay, so number either could be see. First, I will take the first character 1 and then 0 separately. But zeros can't be printed on its own. See, because numbers are going to be from 1 only. It can't be from 0. So first character I can't take alone. Okay, let me take two characters. I can took 10. Okay, 10 can be printed, but whatever the remaining zeros, the remaining zeros can't be printed as such. 0 is not a number allowed here. Okay, it has to be from 1 to 10,000. So again, zeros can't be printed. Okay, I take the first three characters. Okay, it is 100 now. Again, whatever the last zero. Okay, I take again the first four characters 1000. Yeah, 1000 is fine because it's between 1 and 10,000. So there's only one way to print it. Okay, now coming to this is again the same case. Okay, they are given k as 10. Okay, suppose I see. Yeah, I take 10, and then whatever the remaining zeros. Okay, if I take 10 here, then the two zeros can't be printed because the number has to be from 1 to 10. So the only possible answer here is again 1000, like you saw in the above example, but 1000 is not allowed here. So total ways are 0. Okay, and they have given the explanation for that. And coming to example 3, number of ways to print it. See, please go through the example yourself. Okay, you will understand that. See, ultimately you have to print how many ways are possible. Okay, how many ways we can place the comma here. Okay, that is the basic idea. It's a slightly longer example. I will recommend you to pause the video and try to understand it. Okay, it's just a permutation and combination which you have to do. Okay, I will explain the same in code. So coming to the code now, I have taken M as the length of the given string. Okay, M is length of the given string. TP is like a cache mechanism I'm using here. I'm storing the subproblem results so that I do not recompute them. Okay, and I've already told you what is the definition of each of the terms of TP. Okay, DPY is the number of ways in which the string starting from the ith character can be printed. And as I've told you example also, in this case, in this particular third example, okay, DP of 1, that means this particular string, the number of ways in which this particular string can be, sorry, this particular string can be printed is 4, as I have told you here. Okay, there are 4 ways to print it. That is the meaning of DP of I. Okay, this is the modulo in which we will be in each computation. We will take the modulo first and then we will show the results. Okay, This is going to be a recursive function, and I have start calling this function from zero. Okay, I will call the first thing I will call this function with is the first parameter is going to be zero. Okay, let's see how it works. If my if the c dp is initialized with zero. Okay, if my dp of index is already calculated, that means if the result is not zero. See, first I am checking is if the result is already pre-calculated. Please try to understand these points very carefully. Okay, first I'm trying to check if my index, that means if the particular value in my cache is already calculated. When like I am currently tracing for zero. Okay, in this case it is not calculated. Okay, so dp of zero will be again zero only, so this function will not be executed. This I'm doing to ensure that we do not do any recalculations. Okay, if you have already calculated something, we don't recalculate it and we will return it as it is. Okay, and there are two edge cases now. Let me tell you the second edge case first. Okay, if this particular index, okay, in this index if we have a zero string, okay, zero character present, then it returns zero. Why? As I told you, a character, see, they have highlighted it somewhere. Okay, a character cannot start with zero. That is the basic idea they have given. Okay, it's not, there is no example given here, but when you try to run the program, you will understand that. See, for example, in this case you cannot have zero, and see, you cannot have a solution starting with zero. For example, in the third case you're using 317. If I have 017, then it's not counted as a separate integer. Okay, 017 is not counted. You cannot take an integer starting with zero. This thing is not mentioned in this question as such, but when we run the test cases, you will understand this. Okay, that's why whenever a string is starting from zero, there's no way to see, there's no way to print it. Okay, we have to run zero in this case. Okay, next is when we have exhaustion. And see, this condition you will understand only when you trace the below part. Okay, but let me quickly tell you what it is. Index equal to m, that means m is the last index. Okay, when we have exhausted all the index, for example, see, when I have done with all the cases, when I'm after 7. Okay, when I am doing after 7, that means when my string is already fully completed. Okay, then I am returning 1. Okay, this is the return. See, this is the stopping condition for the recursive call. Okay, otherwise it will be going on and happening. Okay, when we have to stop, when we have processed all our string. Okay, when I'm at index m minus 1 and I'm going to index m, then I have to return 1. That is the basic idea. This is going to be the count. Okay, for example, in case of 317, okay, what are the ways? I will select first 3, then I will calculate total ways to calculate 17, total ways to print 17. Similarly, I will select 3 and 1, and I will calculate total ways to print 7. Similarly, if I select 317, total ways to calculate a empty string. That is the basic idea. Okay, so I'm having a count variable to count all the cases. Okay, I'm starting my index from one character after my current index. See, one character after my current index. See, I am at index 1. I'm in index. Okay, this is a variable. Okay, I am starting as follow. That means I will range from a character after my index, so index plus 1, till the last character plus 1. Okay, why I'm taking plus 1? Because I is going to be the ending condition here. Okay, if you are familiar with Python, that means whenever you have I here, na, it will take till I minus 1 only. That's why I want to ensure that I take till m. That's why I'm taking m plus 1 here. Okay, I will range from index plus 1 till m plus 1. Okay, I am taking the number. Okay, starting from index till the ith index. Till the ith index means its range is going to be index and I minus 1. Okay, taking the number. See, I'm converting into integer. Okay, if my number is greater than k, then break it as it is. Because see, if I don't stop now, it will take one more character. For example, if 10 itself is going to be greater than k, then any character after that, if I could, for example, 101 or 100 or 105, anything after 10, if you add, see, if we add 10 plus 5, it becomes 105, right? 10, then add a character 5, it becomes 105. So if 10 itself is greater than k, any character addition after that, it will be definitely greater than k. Okay, so we are breaking as it is in this case. Only if this condition is not true, we are going to count it further. As I told you, first I will select 3. Okay, here I selected 3. Just understand it like that. Here I selected 3. Then I will calculate number of ways to print 17. Number of ways to print 17. That means what are the ways the character after 3. Okay, same I'm doing here. Number of ways to print 17. So I selected till I. Then from I onwards, what are the number of ways? 3. I'm simply adding that to my count. Like I'll repeat, I selected 3. Okay, my index is 0 here. I is 1. Okay, I is 1. So I got this character. Okay, so after I, whatever is the string, what are the ways to print it? That is what I am going to count. Okay, I selected my I here. This is my number. The number is currently 3. Thing is like that. Okay. Now I will add number of ways to print 17. Okay. So we selected till I, index till I, and after I, what are the ways to print it? After I, the string, whatever is the string, what are the ways to print it? That I'm going to add to my count. Okay, this follow will continue as such. Okay, first 3 will be selected, then 31 will be selected, and we'll calculate the number of ways to print 7. Then 317 will be selected, and we'll calculate the number of ways to print an empty string. Okay, all this will be added in the count. Finally, I will update my count in my cache. Okay, this is DP. See, the DP array I'm calling as my cache. I am storing all the results here. Okay, what I will store, I will not store the count directly. I will do it a modulo, then I will store. Okay, and each step I am doing a modulo. You can see here. Okay, and finally I will return the count. Yeah, and this I am calling the function from 0th index and I'm returning the count from answer of modulo. Okay. Finally, also whenever I'm returning the answer, I'm doing a modulo. So if you have to see, I will quickly run and show you this. Okay. Only then see, I'm printing the index and the DP. Okay. See, in my third example, I can go to the third example. You can see DP of 1 is 4. Okay, that is what I have shown you. DP of 1, which is this string, DP of 1 means number of ways to print from C, the first character onwards. Okay, DP of 1 is these are the 4 ways. So it is 4. Okay. If you calculate DP of 17, as I've told you already, DP of 17, if you calculate it, which is DP of 2 in this case. Okay, DP of 2 means from the starting from the second index, starting from the second index till the end, what are the ways to print it? DP of 17 is 2. Okay. Similarly, DP of, we say this 0, 1, 3. The DP of 3, it is going to be 1. Okay. I have taken it m plus 1. Okay. I've taken m plus 1 because see this condition is coming after this condition. So DPM will be checked here. That's why I'm taken m plus 1. Okay, that is the idea. See, I am telling somewhat faster way, but please rewind my videos or pause my videos and try to understand it slowly. See, I have done a lot of work here and I'm making the video. Okay, you may not have done that. You may not be understanding the question. You will be doing it for the first time. So this is not my first time. I have done it nearly. Done modification. If you see the total number of ways in which I've done nearly 10 to 15 times. Then I've got the correct solution, right? So you will not be able to understand it in the initial attempt itself. Okay. Pause the video. Try to understand each and every point. And before that, I will definitely advise you to code it once yourself. Only then you will understand the edge cases. Okay. So I have explained this also. Okay, number of ways to print 317 is 4. Number of ways to print 17 is 2. Number of ways to print 7 is this 1 way. Okay, and number of ways to print empty string is 0. We are not going to print empty string. So this was all about it. I will give you the code. You can trace it yourself also. Yeah, friends, that was all for today. As I told you, this is not going to be hard questions. These are the kind of questions I myself seen in interviews. Okay, so you can explore this kind of questions in an interview. They have given it a harder way, but it's not a hard question. Okay, only thing is, see, one more thing, as I told you, if you don't do this modulo, let me tell you this very frankly here, if you don't do this modulo, you will going to get time like exceeded for the same answer. Okay, for the same code, you are going to get time like exceeded. Maybe that's why they're calling it a hard solution. See, these things you should know. Okay, see, a plus b modulo something, a plus b, let me say modulo k is equal to a modulo k plus b modulo k plus the answer whole modulo. Okay, these things you should know. Otherwise, it's very difficult to solve this question. Okay, that's why I think they're calling it a hard question. If you don't know these things, the answer will fail, even if you run the same code. Okay, that was all about it, friends. Yeah, thanks for today.